Welcome back everyone, Patrick here, moving on to the next example dealing with multiplying polynomials. This is going to be a pretty cool one. So what we have to do is we have to find an expanded expression for the area of each of these shapes here. So notice that there's three of them, and we have to find the area in two different ways. Usually there's actually even more than two ways to do it. We're just going to do two for each of these just to show you can approach these in different kinds of ways. So starting off with part A, over here we have this shape like this, and then notice that this side over here, it has a length of x plus 8. This side here has a length of 5, this side here has a length of x, and then this side here has a length of 3. So we got to find the area of this. Now with this particular shape, what I would recommend doing is splitting it up into two shapes. That's usually the way you're going about these questions. So let's maybe try splitting it up into two rectangles over here. And so once you split it up into two rectangles, all you have to do is find the area of each of these rectangles and then add it up. And notice that we have enough information to do that, because for this rectangle here, we got a length of 5, and then we multiply it by this length, which is going to be x plus 8. So this here represents the area of this first rectangle, and then this rectangle, we have the x, we have the 3, so that's just going to be 3x. That's going to be the area of that rectangle. And then this has to be an expanded expression, so what we would do, distribute the 5 inside the bracket. And then notice the 5x and the 3x, those are like terms, so we'd end up with 8x plus 40, like that. So that is the final answer. That ends up being the area for part A. Now, what if we were to go about it in a different way? Well, notice that we can also create a rectangle here and here instead. Okay, but if we do it this way, notice that we have to do a little bit more work, because with the other rectangles we created, we were given the lengths of those rectangles. Versus here, for example, in this rectangle, we're given this side length of 3, which is nice, but notice that we're not given this full length, either this one or this one here. But notice that we can get it because we have an x over here, and then notice that this length is 5, so that means this length, this dotted length over here, is going to be 5 as well. So if we add the x and the 5, this total length over here is going to be x plus 5, right? X plus this 5 over here gives us that total length. So sometimes you got to do a little bit of work to get these lengths as well, even after you split up the rectangles. So this area would be 3 times x plus 5. So we got that figured out. Now we got to get this area over here. Notice we have a length, which is here, which is 5. So it's going to be 5 times, but this length, notice we don't have that right here. But what we do have is this total length, which is x plus 8, and we have this 3 over here. So this 3, that means that this dotted line here, let me erase this other dotted line. Actually, sorry, let me keep it just because this is what we're dealing with. So this vertical dotted line here, that has a length of 3 as well. So notice that if we have this total length, which is x plus 8, and then we have this dotted length, which is 3, we can find out what this length is, because it's just going to be the difference, right? We could take this total length, subtract that to get this. So we would have to do a calculation on the side where we take the x plus 8 and we subtract the 3. And that would give us x plus 5, right? So x plus 8 minus 3 gives us this length over here, which is x plus 5. And now, let me erase this over here, we can find the area of this second rectangle, right? This first rectangle was this second rectangle is 5 times x plus 5, like that. And notice what happens when we expand. We'll have 3x plus 15 plus 5x plus 25. And then notice the 3x and the 5x, that's 8x, 15 plus 25. That would give us 40. And notice that's the exact same value that we got right here. So it's pretty cool how it works out, how you can split it up in certain ways, and it's still going to give you that same total area at the end. So 8x plus 40 is the final answer. Again, I feel like this one was easier because we were already given the lengths of the rectangles that we split up, but that's not always going to happen. There's actually another way to do this. Another way to do it is you can actually get the area of the total. So pretend this was like a big rectangle over here. And we already know this length is x plus 5, and then this length is x plus 8. The x plus 5 we figured out before. So what we can do is we can take that total area, and then we can subtract this area right here. Because the area that we want is this shaded in area, right? So if we get this total area over here and then subtract just this empty area, then we would get the shaded area. And so notice what happens then. Notice that for this empty area, we have x over here, and then this length we already figured out before with the calculation that that was x plus 5. Right? So this empty area is going to be x times x plus 5. So we're going to be subtracting x times x plus 5. Right? Again, notice how this is a more complex calculation, and it's more complex to go about it that way too. But sometimes it makes sense to do so. So notice here, if we FOIL everything out, we'll have x squared plus 8x plus 5x plus 40 minus x squared minus 5x, right? After we distribute that negative x inside the bracket. So what would happen here? The x squareds cancel out, 5x's cancel out, and we're just left with 8x plus 40, which is the exact same thing we got over here. Okay, so multiple ways to go about it. Whichever way you do it, 8x plus 40 is the final answer for part A. Now moving on to part B, so let's erase all of this over here. So notice that this shape, it's fairly similar, but the information that we are given in this one is a little bit different. So what's going to happen here is we got x plus 10 for this length. We have x over here, we have 5 over here, and then 4 over here. Now before actually splitting it up into different shapes, let's actually just find, if possible, the remaining lengths that we don't have. So let's find this length over here. Notice we don't have that. And then also let's find this length. Notice that we don't have that either. So how can we find this length over here? Well, notice that the total length here is x plus 10, and then this is 5. So this length is going to be the same as that dotted length. So what we can do is we could take the x plus 10, this total, subtract this 5, and we would end up with that remaining length right there, which is the same as this. So we'd be subtracting the 5, so we end up with x plus 5. That would be this right there. What about this other vertical length over here? Well, notice that we're given the total length here to be x, right? And this total length is the same as this total length from here to here. And then we're given 4. We know that this small portion here is 4 as well. So if the whole thing from here to here is x, and then this is 4, well then x minus 4 is going to be this remaining portion. Right? So the total is x, which we got from here, and then this small portion is 4, which we got from here. So x minus 4 leaves us with x minus 4 over here for this length. So let's label that. So we end up with x minus 4 right there for this length. And now we have all of the lengths, and now it's a lot easier to find the area. So that's another way to go about it. Instead of first splitting it up into separate rectangles, just find whatever lengths you can, whatever missing lengths are in the diagram, and then just go from there. So let's try some different methods here. Let's split it up like this first. So notice this rectangle is going to be x plus 10 times 4, right? This is 4 over here. So we'll have x plus 10 times 4. I'm going to put the 4 in front just because that's a nicer way to do it, right? 4 times x plus 10. That gives us this area over here. What's this area going to be? Well, it's going to be x plus 5 times x minus 4. Like that, right? That would give us this remaining area. And then we just have to sum those areas and we end up with the total area. So this would be 4x plus 40 plus x squared minus 4x plus 5x minus 20, like that. So let's simplify the like terms. Notice the x squared, it's by itself. Doesn't simplify with anything. Then we got 4x minus 4x, that's nice. Those just cancel out, and we're just left with a 5x. And then 40 minus 20 gives us positive 20. So that, right there, ends up being the area, x squared plus 5x plus 20. Now let's see if we can get that in another way. So let's actually write out the answer up here, just so we could refer to it. And let's try a different way. So let's, instead of splitting it up into these two rectangles, let's actually split it up into these two rectangles. So let's start off with this rectangle over here. Notice this one is just going to be 5 times 4, right? It's just going to be 20, an area of 20 for that rectangle. Versus this one over here, notice we have this length, which is x. We got this length, which is x plus 5. So it's going to be x times x plus 5. So we end up with 20 plus distribute. So we end up with x squared plus 5x plus 20, which is the exact same thing we got before. Okay, and then even though there's only two ways, let's just do the third way. The third way is to get the total area, right, which is going to be what? It's going to be x plus 10 times x. So x times x plus 10. That's going to give us the total area of the big rectangle. And because we're just finding this shaded area, we could subtract this empty area over here. And the empty area is going to be 5 times x minus 4. So we're going to be subtracting 5 times x minus 4. Let's see if we get what we got over here. So we got x squared plus 10x, distribute, minus 5x plus 20. 10x minus 5x gives us 5x, and then we got a plus 20. So notice we do end up with that same area. Okay, so it's pretty neat how it all works out, right? So 3 different ways, and we're getting the same area. And then maybe on a test, if you just have to do it one way, well, this is a good way to check your answers if you do have the extra time. And then finally, moving on to part C. So let's actually, for part C, let's do what we did here, where we find any missing lengths that we don't have. And then we can create our different shapes. So notice that this length over here is missing. So how can we get that length? Well, notice that we're given this total length, which is x plus 8. We're also given this length, x minus 2, which is the same as this. And we're given this length, which is 4, which is the same as that. So what we can do is we could take that total, x plus 8, and we could subtract the x minus 2. You got to be careful here when you're subtracting the x minus 2, you're subtracting that whole thing, so you got to put it in brackets. So we'll do x plus 8 minus x minus 2 minus 4, like that. And that's going to give us this remaining length over here. So what would happen is we'll have x plus 8, distribute the negative, so we'll have negative x plus 2 minus 4. X's cancel out, so this is actually just going to be a number 6, right? 8 plus 2, 10 minus 4 is 6. So this actually just ends up being 6 right there. Right? X minus 2 plus 6 gives us x plus 4. Plus 4 would give us that x plus 8. And I think from there, that is actually enough to solve whatever we need to solve, because we're given this full length, which is y, which means this full length over here is going to be y as well. You know what? It's going to depend on, no, we're going to have to do another calculation, because notice the way we're going to have to break it down. Let's break it down in a couple of different ways. So let's say that in this case, we're going to break it down into 3 shapes. So we're going to have 1, 2, and then 3 over here. But then for this shape, we're going to have to find this length over here. Give me a sec. Yeah, so this is going to be, if this is 2, this is 2, this is 2 as well, this is 2. So what's this going to be? This length over here for this rectangle. Notice that the whole thing, sorry, I'm not going to put the 2 there because it's going to confuse you. Right, the y over here is this full length right there. Right, same thing over here. The y is this full length, but then this length over here is 2, which is the same as these two. Right, this has a length of 2 as well. So we could find out this small remaining length. It's just going to be y minus 2. Same thing over here. It's going to be y minus 2. Okay, does that make sense? The whole thing is y, and the way we split it up, we need this smaller length over here. But if the whole thing is y, and then we're told that this is 2, that means this is 2 over here. So we could take the y, the full thing, subtract the 2 to end up with y minus 2 over here. This is not a negative, by the way. It's just an arrow pointing to that side. Let me erase that. Right, so we actually, give me a sec. Yeah, we don't need this y for the calculation we're going to do right now. We'll bring it back later, but for this first area calculation, we actually don't need it because we have the x plus 8, we got the y minus 2, which is this length. We have the x minus 2, the 2, and then we have the 2, and then the 4. So we have enough to add up all 3 of those areas. So the first one's going to be x plus 8 times y minus 2. So notice this is going to be a multivariable one. And then for this area, we'll have 2 times x minus 2. And then for this one, we'll have 2 times 4. Like that. And that's going to give us the total area. So if we expand this, just be careful with the algebra here. So we'll have xy minus 2x plus 8y minus 16. Then we'll have plus 2x minus 4. And then that's just going to be 8. Like that. Yeah, we're all good here. So now let's collect like terms. Notice xy, that's just by itself. Then we got the minus 2x plus 2x, that's nice. Those cancel out. We have the 8y by itself. There's no other y term to net out with this one. Then we got negative 16 minus 4, which is negative 20, plus 8 would give us minus 12. So that ends up being the area for part C. So let's write that down over here. And let's see if we could get that same area. This one's a little bit more tricky because there's 3 areas and there's also two different variables. So let's see if we get this area over here with a different method like we did before. So for this one, instead of breaking it down like this, let me erase these. And then let's bring back this y over here. This is y. So instead of breaking it down like that, let's break it down like this. Okay, so from here, what we have is we got this rectangle and we have this length, so we're good there. For this big rectangle, we have this length, which is 4, and then this length, which is y. For this rectangle, we have this 6, but we don't have this length. But we already figured out what this length was before. It was y minus 2. Right? This length is the same as the length of that previous rectangle that we had. Okay, so let's go one by one here. So starting with this rectangle, x minus 2 times y. Because the y is by itself, I'll put it first. So this area is this area. This area is going to be 6 times y minus 2. And then this area is going to be 4 times y. Like that. Right? This area, x minus 2 times y. This area, 6 times y minus 2. And the y minus 2 we got from y minus this small length. And then this area is going to be 4 times y. And then let's add these up. What happens here? So we'll have xy minus 2y plus 6y minus 12 plus 4y. Like that. So there's no xy term, so that's gone. Negative 2y plus 6y would give us 4y. 4y plus 4y would give us 8y. And then we have the minus 12. Negative 2 plus 6 is 4, plus 4 gives us positive 8, and then the minus 12 is right there. And notice, exact same expression that we got before. So it works out with a different way of how we set up the rectangles. Okay, so we could be pretty confident that that's the correct answer. And the third way, what we're going to do is we're going to take this total area over here. So let's fill this out. So it's going to be this big area over here. And notice that we have this length, which is y. We have this length, which is x plus 8. So the total, the large area, is going to be y times x plus 8. And then we're just going to subtract this empty area over here. Notice we have 2, and then we have 6. So we're just going to be subtracting 2 times 6. Actually, in this particular case, I feel like this is the easiest way to go about it. And notice how little of calculations there are here. So notice when we distribute, we end up with that right there, and then there's no like terms to simplify. And notice that this is that same expression that we got before. Okay, so with these kinds of questions, what you want to do, split it up into multiple shapes, then add the areas of the shapes, or you can create a big shape and then subtract any empty areas.